Example 2. 2x to the 5th is equal to 16x squared. Again, you are more than welcome to pause the video and see if you can come up to the correct answers for this problem. Step number 1, we need to set one side of the equation equal to 0. So I'm going to move my 16x squared to the left-hand side because I like my highest exponent positive. It makes my next step of factoring completely easier. So I subtract 16x squared from both sides. That gives me 2x to the 5th minus 16x squared is equal to 0. So we have finished step number 1. Step number 2, factor completely. Our first factoring step should be to look for common factors. And we do have some here. We have a common factor of 2 as well as x squared. So if we take that out, that leaves us with a positive x to the 3rd minus 8. And that is of course still equal to 0. I am not done factoring completely because this one here, x squared minus 8, factors farther. It is a difference of cubes. And you might want to rewrite this as x cubed minus a 2 cubed. That helps us put it into the formula of difference of cubes. So I'm going to carry down my 2x squared. And remember that formula of difference of cubes has a short parentheses with 2 terms in it, and then a longer set of parentheses with 3 terms in it. And that's still equal to 0. My short parenthesis here comes from exactly what I see up here, but without the cubes. So I'm going to put in an x minus 2. Then in my first spot, I take my first term, which was x, and I square it. In my last spot, I take my last term, which was 2, and I square it, and 2 squared gives me 4. And in my middle term, I multiply these guys. So I have 2 times x, which gives me 2x. Now I need to put in my sign. If this sign was negative, that means this sign is going to be positive because they are always opposite of each other. And this sign here is always addition no matter what the rest of the problem looks like. So we have factored this completely. Now this guy here might look like it factors as a trinomial. It will always resemble a trinomial. But remember, I gave you that hint that it actually never does factor as a trinomial. So now that we have factored completely, now we need to set each of our factors equal to 0 because this is in the form of all multiplication equal to 0. So my first piece, 2x squared, is equal to 0. My second piece, x minus 2, is equal to 0. And my last piece, x squared plus 2x plus 4 is equal to 0. Let me start in the middle one. That's the easiest one to talk about. So we're going to add 2 to isolate my x here. And that one gives a solution of x is equal to 2. So that gives us one of our answers. Moving over to the first one, I want to isolate my x, so the first thing I do is divide by 2 on both sides. That gives us x squared on the left, and that gives us 0 on the right. So technically to solve this, I need to force in a square root to both sides, and technically if I do that, that gives me plus and minus along with my square root. So on the left, my square and my square root cancels out, leaves me with x. On the right, I have square root of 0, which gives me 0. And technically, I still have plus or minus, but it doesn't make any sense to have a plus or minus 0. So this gives me another one of my answers. But this one actually gives me 2 answers. It gave me a duplicate answer. So So instead of solving it by using square roots like I did here, let me look at it a different way. Where I have x squared is equal to 0, I could split this up. Where I have x times x is equal to 0. I could then again use the principle of zero products, which gives me the first x is equal to 0 and the second x is equal to 0. Now, that gives me the same answer twice, which is why it's not really necessary to work it this way, which is why if we did it the first way, that would be perfectly fine. But I did want you to see that we do actually have two answers here. So one way that we note that it's a duplicate answer is we might state that it's multiplicity 2, meaning that we have that answer twice. And when I'm done solving the rest of this problem, I will explain why it's important that I do that. Now let me look at my last guy here. X squared plus 2x plus 4 is equal to 0. Now, I said this doesn't factor, but we still need to figure out what x is to solve this. Well, this is a quadratic equation. And if I cannot solve a quadratic equation by using the factoring method, then I can solve it by either completing the square or by using the quadratic formula. I prefer to use the quadratic formula, so that's what I'm going to do with this here. My a variable is 1, my b variable is 2, and my c variable is 4. And I set my equation up as x equals. So x equals negative, my b variable is 2, plus or minus the square root, my b variable of 2, but when I square it, it gives me 4, minus 4 times my a variable, which is 1, so I'm not going to put it in there, it doesn't affect my problem any, times my c variable of 4. And that's all over 2 times, again, 1, so I'm leaving that step out. So if x is equal to negative 2 plus or minus 4 minus 16 over 2, and x is equal to negative 2 plus or minus the square root of negative 12 over 2. Now with my square root of negative 12, I can do a good pi and a bad pi with it. The good pi, the biggest square that goes into it evenly, is a 4, and I'm going to put my negative over there as well. And 4 times 3 gives me the negative 12. Now simplifying the good pi, square root of negative 4 gives me 2i, and then carry down my root 3. So I have x is equal to negative 2 plus or minus 2i root 3, and that's all over 2. But instead of writing it all over 2, let me split it up and let me write each fraction over 2. That makes it real obvious to see that these two cancels out to give me 1, and that these two cancel out to give me 1. So my answer here is x equals negative 1 plus or minus I root 3. So that gives me this answer here. Okay, let's kind of recap everything that happened in this problem. First, let me mention that this is a degree 5 problem. So I should be having 5 answers. Starting with my right, I have 2 answers here. The first one is negative 1 plus I root 3, and the second one is negative 1 minus I root 3. So that's 2 answers. My third answer is x equals 2. And then my fourth and my fifth answer is here, x equals 0. That's why it was important to say that I had multiplicity 2. Because I need to know that my number of answers match the degree of my problem. So I wanted to put that multiplicity 2 to tell myself I had 2 answers there. Now all I have to do to finish this problem is put my answers all in one box. And the problem is most likely going to ask for the solution set, so we should put these in braces. Now you don't need to list the duplicate of 0, so you just only have to list it once. So my answers are 0, 2, -1, plus or minus I square root of 3. And if you wanted to split this up, those two answers, that would be perfectly fine as well. So that there is our final answer to the problem of 2x to the 5th is equal to 16x squared. So here's a couple of examples of how to solve higher degree polynomial type of equations. You just factor it the same way that you did quadratic equations, and if you need to do any extra work along the way, don't be afraid to do it.